Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. On Friday we actually did some stuff to the entity system that we didn't really get a chance to finish. We implemented this new system that I wanted to use, or wanted to try out, as far as how we would create control code for entities that were more complicated than just a simple single unit that moves around. And so what I wanted to do was finish that up today. Or I shouldn't say finish it up, but at least get it to the point where I could actually test the thing I wanted to test. Because we implemented the basics, but we didn't actually go and finish the actual system. So let's take a look at that. Today, as I just flashed, is day 288. So day 287 source code is the source code that you're going to want to start with if you're trying to follow along with the series at home. All right, so let's load up Handmade Hero here, and if I remember correctly, we left it compiling, but we hadn't yet actually ported over the full feature set. So it's compiling, but only it's like just nominally like compiling. It's not actually doing anything. So for example, I am unable to control the hero, right? So we're still booting and all the entities show up where they should show up, and that's all fine, but the controllers aren't actually executing yet. And if you remember why that is, it's because we haven't actually gone, excuse me, let me load this up here. We haven't actually gone and implemented any of that brain code. We just sort of put it in place and created the entities with stuff in their brain type, slot, and ID. But we didn't actually implement the hash table that loads them in. We just kind of left it there. So right now, there's never going to be an actual brain triggering when it goes to loop through the array of brains. Sounds like something a zombie wrote, to say the least. So anyway, if I come in here and look, you can see that we created the notion of a brain hash, right? There's a brain hash right here. And we also have this concept of max brain count and brain there, right? And so we have the trappings of a thing that stores and executes these brains. We just never actually made any of the actual brains. And so that's what I'm going to go ahead and do and sort of make that start to happen. So let's take a look here in, let me see. Let me take a look in sim region. All right, sorry, I just wanted to adjust my chair. There we go. So if I take a look in sim region, there's the part where we sort of push onto the entities. And that's here in add entity, right? You can see that. We're going to need essentially the same thing for add brain. Right? And what we want to do here is we want to, I guess, so I'm curious here. It looks like our rule when we did add entity, when we get this entry, is we assume that if someone's calling add brain, that means they've already tested the hash table and they didn't find anything in it. Now that's a little bit odd to me, to be completely honest. I'm not sure because we're already doing this hash lookup here. It seems to me that we would want to check to make sure we hadn't already added it, or rather that we would have done a lookup already. But I guess the nature of it is, that we don't, because we know that we're loading them. So I feel like add brain is going to be a little bit different. I feel like add brain might be like get or add brain, in the sense that I feel like this is one where you're going to constantly try to add the brain multiple times. The reason I say that is because unlike the entities which are packed uniquely into some place in the world, brains are created spontaneously when patterns of entities are seen in the world. And that means that when we see an entity with a particular brain type and an ID, we're going to be trying to create that, but there may already be that brain in our simulation, and we're just trying to attach an entity to it. Right? And so that's the thing that I think differentiates these two. And it's what I think means that we will want to make it so that this is a single function that either creates or returns the same brain. And we don't really need it to even do the return probably. We'll probably won't use it. I'll do it anyway here. But really what we're saying is just, hey, we might not always add one. We may just take one that we already had and return it. Now, I don't actually know much about the world mode situation here. Like, for example, I don't know why this is taking a world mode. It's really only a sim region that it needs. Maybe there's something specific going on there, but I'm going to remove that from here for now because I don't actually know what it's doing there. And I don't like having parameters lying around that I don't know if they're actually being used. So I'm going to keep it out of there for now. We can always add it back in if we need it. So that's fine. So what I want to do here is say, okay, there's a sim region. And what I want to do is I want to be able to create a brain. And you know what? We are going to need this because we're going to have to insert entities into it. So we are going to need to return it. I take it back. We actually will use that return, I think, almost right away. Now, I just wasn't thinking it through quite all the way. I think that'll actually happen. So if we want to create a brain, really all a brain is an ID and a type and then a bunch of slots, right? And we haven't quite gotten to the slot part of things yet, but we know that we're going to need a brain ID and a brain type. So at a minimum, you're going to have to pass those two things if you want to create a brain. And then what we're going to do here is we're going to say, all right, we've got a result brain, and we're going to return that. Result brain, and assuming that we can't find that result brain, then what we're going to have to do is we're going to have to create a new one, and we're going to initialize its settings to the settings that we are given here, like so. So the first question is, where is that brain coming from? Well, the way that we're doing it here is we just push them onto this sort of stack, right? And we're going to keep that for now. That may change in the future if we want to make sure that we can go to as many as we want and grow dynamically. We may change that. For right now, we certainly don't need to because we're treating entities this way. We can treat brains this way as well. And so we're just going to leave it like that for now. So here we'll just allocate a new brain off the stack. And just so we know later on as we're sort of moving through this, we want to make sure that we don't have... oops, sorry, it's max brain count there. We want to make sure that we never overflow that because we want to know that. Again, we may change it later so that it can't overflow. It'll just grab more memory or something like this. But for the moment, we just want to make sure we don't hit that case and wonder why we're having a bug. So that assertion is there to protect us from that during development. So here we are getting our brain and setting it and then returning it. So the only thing we need to do now is use that hash table. So we want to have a brain hash here. And we want to sort of do that same get hash by ID where we're going to ask for a hash. This is asking from a different hash table, certainly than the other one. But I guess in this case, yeah, we don't assert, I suppose. We just say that result equals whatever the hash pointer was. And so in this case, if we find that the result wasn't equal to anything, then at the end, we also want to make sure we set the hash pointer so the next person through will find it properly. Okay? That's pretty much all we need. The only problem now is we don't have a hash table for these particular guys. That's no real big idea. Wow, talking. Big problem. Really all we need here is another one of these. And this one presumably will work roughly the same way. We could almost use the same hash table for these things, but or the same hash table code, but I don't know that it's worth trying to like make sort of a templatized version of this or anything like that. I tend not to super like things like that, especially when the code is so straightforward and there isn't very much of it there. Because you never know when we're going to want to specialize these things or do other things in that case. So I feel like, yeah, brain hash... pretty much the exact same code here, really nothing particularly unusual. I think we pretty much do exactly what we're doing. And so I think it's pretty much just that. I don't think there's really much else to it. Now, let's see. Brain hash, I think we made the name of this thing be ID, and we probably should make the name of the other one ID as well. But we can always do that a little bit later when we're cleaning things up. So let's see. In this case, we got to return a brain hash, obviously, not an entity hash, but that's fine. And yeah, we also have to change this to a brain hash. There we go. When we do add entity, we remove the world mode parameter for it, just as some cleanup while I was moving through there. So there we go. We're good to go. What I want to do now is I want to say, all right, when we do add entity here, what we want to do is every time we add an entity, we're going to, and this is the only place we do that at the moment, right? So that add entity call could actually be sort of streamlined in here if we wanted to. I don't know what add entity raw is. You know what? I have no idea what that does. I don't think it does anything, so that should probably go away. Add entity is actually code that you never call unless you're doing an unpack. And so actually, really, this could just be included directly in that unpack. Which might be actually a little bit better now that I think about it. So, you know, it might be that this is really the right way to do it, is to have this all in line, because I feel like this is just a giant, the giant unpack function probably is going to want to be something a little bit more direct like this, right? And so I think what I might do is say, okay, let's say that this is just dest right here, and then we sort of do a thing where we check for the overlap, and then when we come in here, we do that. Oh wait, no, sorry, that's not true. It's source. Again. We check that, and then when we're done with that, we can kind of come in and say, oh, okay, we've got the rest of the stuff here. We just do our addition right in line. And that seems like a fairly good idea to me. So it's all, we get rid of that stuff and make it a little bit more straightforward there. Okay. Let me just double check that that's all fine. Yeah. All right. So anyway, here we are inside the unpack function, which does all of the sort of unpacking of the world into a simulatable state. And what I want to do in here is I want to, whenever we've added an entity, right, which is this sort of thing here, whenever we've added an entity and we've finished doing that, assuming that the entity is updatable, I think we would want it to have a brain controller. Now, I guess even if it's not updatable, we might want it so that the brain knows it's there and just not simulatable. We haven't really done much with the updatable stuff. That's going to probably stuff is going to change a little bit in the future to be a little different than it is right now, but we'll sort of ignore that for now. Anyway, point being, in here, what I want to do is say, well, if this destination, we've got this sort of notion of the brain type on the entity. And what I want to do is say, if the entity's brain type is something that is non-zero. And I don't know, I guess it's not type, I guess it was ID that we said. If the brain ID is non-zero, then I want to create a brain for it. So I'm going to do an add brain here, and I guess what did we call it? Get our add brain. Yeah. So I'm going to pass the sim region here, and then I'm going to pass my brain ID and my brain type. And I don't remember which order we passed them in, but I'm sure the compiler will tell me in a second. So that was the order we passed them in. So once I have a brain and I've got my brain ID and my brain type, now the only thing I really need to do is I need to figure out how we actually store these things, right? Now this is something that I said, if you remember I alluded to, I said we're going to do some stuff here that's going to be a little more complicated than what I do up front. What I'm going to do first, just to get it working, is I'm going to say that there is sort of just this collection of brain slots. Where's the sim region? Here it is. These are probably going to move out into a different location in the future as well. So there'll probably be a file that's like brain.h or something, right? But for now, I'm going to put them in here. So we basically have, we have the entity, and then we've got the brain as well. So there's the brain. And what's going to happen here is inside the brain, there's going to be something that looks like this, which is like, members or something, or parts. To be honest, I really don't know what this is going to be called. But then there's going to be some number in here, right? That's like the maximum brain parts. And I don't know how many there's going to be. This is probably not exactly how it's going to go, right? It's not going to look exactly like that, but it's going to look something like that. And probably, honestly, what we'll end up doing is something like this. Where we sort of have like, okay, there's a union that's all these entity pointers if you just want to know what the random pointer is inside it. But then there's also, something like this where, we have, if it's a hero brain, then it's got, entity star head and entity star body or something like this, right? So, that's the sort of thing that we'll probably end up seeing. I don't know exactly how we're going to do it, but it'll be something that looks a little bit like that. And so, yeah, that will happen. We probably, and to be completely honest, we might even do something like this, hero or brain hero parts or something like that, where we do entity head and entity body. We might even do something like that, where we just say like, oh, okay, if you're a hero, we just do something like this. So now we can access them in either as named things if we're doing a particular brain, or as just a generic list of things if we're not, right? And so it'll be something like this. I don't know exactly which one we're going to do, right? So that'll sort of shake itself out a little bit further on. But anyway, point being here, what we'll do inside the inside this situation. And these are going to get more complicated later if you can have more of these, right? But what we're going to do here is say, all right, the brain, everybody has their sort of slot. You remember we said in here, we've got the brain type and we've got the brain slot, right? So the brain slot has a value, and that tells us where we go in here. Now I can assert that it fits so that we don't have any kind of weirdness going on. So I figure like, okay, yeah, make sure that it fits, but assuming it fits, the destination entity goes into that, right? So now we actually are building for reals these controllers, yeah, and that's just how that goes. Is it index? Is it actually? I think it might be index. Let me see. Yeah. So now we should actually be building brains, but we're not actually. Oh well, you know what else we got to do? We have to actually allocate some. So the other thing we need to do is, when we create a sim region at the moment, I think we don't have a max brain count happening here. So, and actually, you know what's interesting is, yeah, okay, so yeah, we would just want to in here say, how many brains can you have? And I don't know how many brains you can have, right? I have no idea what that number is. But and I'm just making it up. Certainly, we want to actually do some work here to figure that out in the future. Once we actually have like the whole game, you know, sort of running, we'd come back and figure this sort of thing out. But for now, we just need some for testing purposes. Oops, and so now we've got them. Now, we haven't actually done anything with these brains yet. So in theory, nothing should happen, and as you can see, nothing does happen. But we are now at least creating them in theory. So for example, the hero should have a brain created. What that means is that if we pop back to world mode and take a look at where that sort of brain situation happened here in Brain Hero, you can see that we never actually fill these in, right? And so what we'd want to do is put these grab them out of the hero, right? We'd want to say, okay, I'm sorry, grab them out of the brain. So we'd want to say the brain hero.head is what we're looking for there, and hero.body is what we're looking for the body, exactly what you would expect. And then when I go ahead and run that, now in theory we should actually have, and you can see we're starting to get that information, right? You can see it, we're actually standing on this guy now, so that code is actually running. Because I don't think that runs elsewhere. Could be wrong about that, though. All right, so now we have to actually figure out, I don't know, in fact, let me see. Are we actually running this code? We might not actually be running the code. We got to verify that. Yeah, so we are actually running this code. And you can kind of see that because I can spam the world with these guys, right? I remember that code that just looks for the closest unoccupied point to us and sticks people on it. Whee! All right. Don't ask me why I did that. Don't know. Also, you know, I was noticing that we never deleted add entity, so I'm going to go ahead and delete that. Goodbye. All right, so we've got the brains working now, but we've got to actually make sure they really actually do what they need to do. And if I remember correctly, part of the problem there was we sort of had this old janky way from way back when that we were using to move people, which is instead of actually calling or putting in a move request into the entity itself, we actually had that move request sort of cascade through. I don't know if you remember this, but basically what was happening there is inside, you know, down at the end, can't remember where we actually were doing this. It's like, yeah. Down at the end, you know, we'd have this thing, you know, if this thing is movable, then we would call move entity on it with, you know, with its acceleration value or whatever. And so what I'd rather do here is I'd rather make it so that that's actually, because now we're going to be doing packing and stuff, what we want to do is be able to sort of put accelerations into objects and have them just do those accelerations later, right? So brains can assign a bunch of accelerations that it's trying to do to whatever parts it has. And then later when the physics kicks in, which is going to be sort of this separate wave, which it already kind of is now, that'll just happen, right? And that's how we want that to work, ideally, for a number of reasons anyway. Not the least of which being, if we don't know the accelerations of objects, when we go to do collision detection, we have a problem. I'll give you a real simple example, right, of this, is... And I know that, I don't know if Sergio is watching. I apologize, I've not updated Milton yet. I know he's freaking out because he had a bug in the latest Milton. and he doesn't want the Blackboard for Handmade Hero to get lost. I appreciate that, but I'll be honest, no one's ever going to use these Blackboard files anyway. So after I'm off the stream, I will try to remember to update Milton. But either or, not really a big deal. Anyway, so what I wanted to say was, so DDP, right? So what happens in our system, right, because we did a little basic physics thing back in the beginning when we were sort of getting things sort of started, but we never really did our final pass on it. And that's okay, because this is the whole point, is we wanted to get to the point where we had things like brains doing stuff. We want to keep incrementally building the engine, which is exactly what we did. And so then you always are implementing the thing at the time when you actually have information. So a lot of times it's not really a good idea to do a really full version of something until you know what's actually going on. And so the case that I wanted to talk about here is, if I was to move each entity in turn, like we were doing before, then we have this problem of, let's suppose that both of these entities are moving in this direction, or want to move in this direction, right? Well, because they're right next to each other, if I happen to try and move this one first, right, it's going to hit this entity, and it can't go the full amount that was going to go. Even though if we just looked and waited and saw that this entity was going to move as well, if he was the second one to move, we would then know that this guy could have moved to where he was going to be, right? So you end up with all these fractious micro-bumping things happening if you don't first assign all of your accelerations and then simulate the people together, right? Because I would know where this guy was at this point in time if I knew what his acceleration was, right? So you want to try and do as much simultaneous movement as you can. So you want your brains to go and assign all of their accelerations so that you know how everything's supposed to move, so that you don't end up hitting each other in times when you shouldn't actually ever hit each other, right? So yeah. So we come in here and we get something like let's see, where is it? The hero controller. Here's Brain Hero, right? And what I want to do here is I want to actually assign DDP to the actual hero. And you can see we've got some weird stuff happening. We've got these like brains getting iterated, and then we also have like the controller stuff here happening. So the controller stuff happens down here. We kind of want to integrate this stuff in, I think, right? We want this controller index, this controller stuff to be a little bit more sensible than it is right now. Right now it's kind of janky, and so we're going to try and probably fix that at the same time, hopefully. So let's start out by doing something a little bit more straightforward. Let's start out by just drawing whatever that DDP actually is. So I'm going to say that from now on we're storing in the entity, we're going to store the DDP. Now note that that's not something that actually has to get packed, because acceleration doesn't persist from frame to frame, only velocity and position do. And so the DDP is strictly an accumulator so as that we know who's actually trying to apply forces to these objects, right? That's all we're trying to figure out here. So we never actually need the DDP to be stored in the permanent record. It's just a temporary accumulator so that everyone who's trying to push on this thing can push on it, right? And then later we can figure out what that actually means. Now, to be honest, I guess I don't know that we really need to do that, because there's a number of reasons why maybe we don't, but I'm just going to do it that way for now. We could do it directly into the velocity, but I'm just going to do it this way for now because I feel like it's a little more straightforward. So what I want to do is I want to sort of change this controller code around a little bit. You can see here that we've got controller code that's iterating over these things. And in this case, it's taking a look to see if a controller doesn't have a player assigned. If it does have a player assigned, it's going to, if it doesn't have a player assigned and they push the start button, it's going to create a new player. All right, we want to keep that code. That code makes a lot of sense. We do want that to happen, right? So we're going to make this piece of code stay here. Note Casey. This is like look to see if any players are trying to join. Because that's what this code does. It just looks for any controllers that are trying to hit start, right? So that's all fine. Then the next thing I want to do is like, you know, run all brains. And so when we're running the brains, what I want to do is figure out a way, and I don't think this is going to be particularly hard, What I want to do here is figure out a way to make it so that instead of having to do this weird like looping over the controller nonsense, you remember we had this nonsense in here, right, where we loop over the controllers to see if any of the controllers pertain to our hero. That's just dumb because we should be able to, now that we have this solid concept of the brain which is controlling the entity, it seems like we should be able to do something much more solid, which is just go get whichever controller is the one that corresponds to this particular hero, right? Doesn't seem particularly hard. So I want to take that code out, and I want to put that code in, and I want to put it over here, right? So right where we're about to do that work, like this, we know we're always going to have a controller if it's a hero. Because if it wasn't, it probably wouldn't be. I mean, we could still double check to make sure that's true. But if it wasn't, then it wouldn't really be a hero. What makes a hero is the fact that it's got a connection to a controller, right? And if we were going to have another brain that was similar to a hero but used its own control logic, well, we would make another brain type for that probably. And then they'd share perhaps a bunch of code, but that would be the primary difference between the two controller types. One is from a controller and one is from a artificial intelligence of some kind. Okay. So if I go in here and now do a thing that sort of gets that controller stuff happening, then you can see what I want to do is if I'm calling this code where I get the game controller from the controller index, right? All I need to get started is I just need some notion of what that controller index is, right? So I just need a way of having the controller index properly correspond in some way. That's all I'm looking for here. And once I have some way to get that controller, then the rest of the stuff that I do can all just work. And similarly, in this case, I don't really have any circumstances right where I don't really have any circumstances where I wouldn't have a con hero anymore. And like I said, we can make, like if we want to make the little hopping zombie guy, we can now make that guy by sharing code. Perhaps we'll share a bunch of this code, but we wouldn't want to make it be the same brain type because I think we want this brain type to mean I get my control from a controller. And then we want other brain types for things like zombie or whatever, right? And there's a bunch of more stuff we can do to that regard, but you get the idea. So that's how the controller stuff works, and then this stuff doesn't really have to happen. In this, the test hero stuff doesn't have to happen. Instead, what we can do is just directly use this code. And because we don't have a real way to add one of those zombies anymore, I'm going to if zero this out for the moment, right? And maybe we'll go ahead and re-enable that and actually make a zombie brain that works the same as the hero brain as a test case, which actually sounds like a great idea to me. So all the rest of this stuff just works, and there's really no modification that has to happen to it. So presumably all that should happen now is we just don't know the controller index. So the question is, where do we get the controller index? Well, I'm going to be Mr. Sly Pantsy Man, and just say that, well, where we get the controller index should probably just be based off of the brain ID. Because we can just reserve a slot of brain IDs for all the controllers that we might have, and then we know that the actual brain ID itself maps directly to which controller we're looking at, right? And we can sort of assert here. I don't know what get controller actually does, I'll be completely honest with you. I don't really remember if it checks. So it just does an assertion. Yeah. So, all right, so I don't have to reassert there, it's gonna assert for me. But the controller index can just be whatever the brain ID's value is. And if 0 is not a valid brain ID, which I'm pretty sure it's not, then they would just start 1, 2, 3, 4, right? So what that means is that our controllers are numbered from 0, I believe. And so what we probably want to do is just subtract 1 there to make, right? But to make that a little bit more festive and creative, let's say that we actually have a numerator for it, and we'll call it like brain reserved or reserved brain ID underscore first hero or something like this. And then what I can do is say, okay, with those brain IDs, we just know right off the bat, right, that we're going to require those slots for brains to be reserved. So, you know, in here, well, actually, you know, I could do it right in the entity as well, where we're talking about brains. So in here, I could do something like enum reserved brain ID kind of a thing. And in here, there's like the first hero is reserved at 1, and then you know, there's reserved brain count, or something like that, or I should say first you know, first free ID or something like that, right? Yeah, something like that. And so then in here, I do reserved brain ID last hero. And the last hero would just be, you know, the first hero plus however many controllers there are. So in the platform code, you can see that, you know, we want 1 per controller. So it's going to be the array count of however many of these are. I'll make a pound defined for it, because why not? Max controller count. And that way it's a little clearer what's going on there. But that way we can just say, well, we'll just reserve however many there are, and then however many there are, we now know that that's the last one, right? Now, since we don't really have to reserve the very last, all of those, because, you know, we've got first hero, it's 0 based, right? So we don't need, you know, it would be, the value of first free wants to be the one after the last one you'd use. So I'm going to take back 1 there to make sure that we only reserve the ones we actually use. Not that there's any penalty for not doing it. We've certainly got plenty, but you get the idea. So that's what's going on there, right? And what I'm going to do up here is the reverse. So when we add a player, instead of it returning me the brain ID, I actually want that brain ID to be something that I pass in. So I'm going to say here, okay, I've got brain ID for this guy, and it's going to be whatever the controller index was, plus whatever that first hero is, right? So I now know that that's what my brain ID actually is, and I'm going to pass that in, right? So now in that add player code, instead of that returning the brain ID, it's not going to do that. It's going to take the brain ID in. And it's not going to be, this add brain thing is never going to happen in here, because it's been, you know, it's sort of something that's only for when you're adding to the end of that free list. So then what we need to do is when we initially create the brains themselves, we need to make sure that we start out with the first free brain, and we don't ever like actually use any that we haven't, any that are reserved, right? So what we're going to do there is say, well, okay, where we're getting the brains from, it's kind of some weird things that end up being said when we're talking about this. Where we're getting the brains from inside our storage indexes here, right, is I guess this last use entity storage, and I guess we're using the same ones for that. So what I want to do is, I guess I could just still even do it, make sure that that starts after the first, because reserved brain ID. Now we could split these into 2 arrays, but at the moment we don't really care too much about that, so I'm just going to make sure that no entities are in that range either. We just have a range we start after, right? So now that should be fine. And I think that's basically it, right? So now we should be actually creating one that goes with a particular controller, in theory anyway. Now that doesn't help us, that's just what we needed to do to make things cleaner in general, but that doesn't help us, as you can see. Oh, well, I guess it does. I was going to say it doesn't help us with the DDP thing, but it does help us see that we're actually now connected to the correct hero, right? Because I can change his facing direction, since that's not something that relies on the acceleration. But we still haven't put the acceleration back in, and like I said, in order to put the acceleration back in, we just need to start treating that as sort of an accumulation, right? And so now when we have some of the things that were in that con hero, we don't actually need to be in the con hero. So the DDP is actually in the entity now, does not need to be in the connected hero. So now some of the things can come out of there, which were not really ever, you know, shouldn't actually be in there in the first place. Handmade, oops, handmade.h. So let's see where that is. Controlled hero. First of all, we don't need the brain IDs because they're mapped implicitly. We don't need DDP and DSword or DZ. We really just need, I don't even know if we need exited. We might need exited and debug spawn. I'm not totally sure we do. You know what? I don't think we need really anything but the recenter timer. I'm pretty sure that we don't need anything but the recenter timer, but we'll find out in a second, and we'll go from there. So I'm pretty sure now, you can see that this just cleaned up things a lot, right? Because now everything's in the correct place. We don't have this weird like storage thing going on that we don't really need to have, that we didn't really want to or need to have happen in the first place. So we'll keep desort in there. We need to rename it because that's not what it means anymore, but you know, for now we're just, as we're doing the code transformations, it's fine. You can see us initializing these things here. These were getting initialized already, so we can just make those two happen. I don't know what exited and debug spawn really need to be, but at this point we'll just clear them to 0. When we come through here, then all of the things where we had con hero DDP before, we just want to have entity DDP instead, right? We're just going to go ahead and set those. Although, you know, to be honest, I guess it might be more fun to just have DDP be something that we can create directly, and then we'll set it later. Oops. What do I want to do here? Oh, no, that is what I want to do. Con hero DDP with just DDP. So I'm just going to go ahead and, oops, what did I do? I need to remember to make automatically repeat last replace. I haven't done that in my custom file yet. I should. All right, so we're coming down here, doing some stuff. So yeah, when we create these DDPs, then what I want to do is finally set my entity DDP equal to whatever the one is that I got there, right? For the most part, I think, I don't really remember what the things are that we wanted to do. I think that's true. I think that's true. Do we do anything with that? So I guess that's not even true. It looks like. It looks like we don't even want to assign that, because it looks like we're manhandling it here to a large extent. Right? It looks like we're just straight up setting the velocity. Am I right? Huh. I'm sort of confused right now. I'll be completely honest, because I didn't realize that we just straight up set the velocity. Is that, gosh. Huh. But I mean, seems relatively incontrovertible since, like, that's what we were doing. All right, well, you know, if that's the case, then we just do that and off we go. But that's not probably what we should be doing. I mean, probably what we should be doing is setting this in here. So we got a bunch of cleanup to do here, because that's not what I even thought we were doing, but I guess we just never really wrote that code for real, which is fine. Oh, looks like I spoke too soon. I guess we do need to store, we don't really actually need to store the brain ID, but it looks like we want to store something there so we know that it's assigned, right? So that's, yeah, I guess that does make some sense. So yeah. Yeah, let's take a look here. So if I set that in Handmade H, then when I do my add player, it just looks like this. All right. So this was some holdover stuff that we don't really want anymore. I'm going to get rid of it. Let's see. Our debug spawn is set to true there. That's something that we'll, I guess, deal with a little bit later. Let's see. We've got our dsort. Con hero dsort is just going to be dsort. Oh no, that was behind my head. Couldn't see what I did. Okay, yeah, that seems reasonable. We need to process that exited code. Are we processing that down here? When do we actually process? Yeah, we do. So if we exited, we set that to false. Well, we don't really need to do that. We delete the entity and set the brain ID, so that's what we would want to do anyway. So that's all good. All right, so our DZ, con hero DZ, I don't think we want jumping in there anymore, so that's gone. So I think now we're back to everything trimmed out and going through the brain. So now we just have to actually get this guy back in motion. And so setting the DP directly means all we have to do is call move entity on the hero, but I'm not sure. Yeah, like I said, I was kind of surprised at how that was going. Anyway, it doesn't matter, but we're gonna have to make the rest of this stuff go. All right, so let's see what we've got here. There's the switch for entity type. Most of the code happens in the hero struct now. So it looks like what's happening here in the movement mode code. I think this stuff, I mean, just looking at it, this stuff really wants to be probably more. So this looks like this is going to have to be a slightly separate stage of things, right? So the idea here is we want to be able to share methods of movement. So we kind of have the like concept that something's planted versus the concept that something's hopping around, right? And so what we'd like to do here is we'd like to make this be a little bit more separated from the notion, like this bit doesn't really make sense in terms of planted, because this part right here assumes that you've got a notion of someone you're leaning towards, which is not true for general planted people, right? So it feels like we want a little more granularity here. Hopping looks about correct, right? Because hopping just says, hey, look, if I'm trying to hop from one place to the other, here you go, right? And it doesn't really require any sort of, that doesn't really require any sort of knowledge of other people or what's going on. So if an entity is in a hopping mode, you can see that it just sort of works. And so it's really just the sort of the part inside planted that's not okay. And we can get rid of that temporarily because planted is not a particularly interesting movement mode. You just stay where you are, right? So that's really not so bad. But we're going to have to sort of take these one by one because there's just a lot of code here and we're trying to sort of sort these out a little more cleanly. What is the complaint here? There is a null entity. Ah, I see. Entity occupying an entity came from. Inside get sim space traversable. I am not sure. I'm not sure what's going on here. Which entity are we updating right now? We're updating brain type, brain hero. So we're updating a hero. We're updating the body of a hero, right? And it is in the hopping mode. It's trying to update its came from, but there is no came from, which I guess is the problem. So how did we get into hopping mode without a came from? It's a reasonable question. Let's take a look. So in order to get into hopping mode, we would need... Where is that code? Here we go. In order to get into hopping mode, we need to get here. Right? And when we do that, we have to set came from. And so you can see, I guess, when we first start up, I guess were we not occupying anything? Yeah, index 0. But we did set the pointer. So at this point, both came from oh, no, okay, but we set it in transactional occupy. So, okay, so came from in this case is, occupying, I guess, was originally set to nothing, which doesn't really make sense. It should have been sent to something. right? Because occupying is supposed to be initialized. At least I believe that should be true. So when we were on add player, right, we should have set occupying equal to something, and maybe we never did. But it seems like it should be. So I wanted to see what happened there. It could be that our packing code is not right yet, because we didn't quite do as much of that as we should. So you can see we set that there. And then when we call end entity, it should be packing the body in, it should be packing that properly. So here we are in the packer. And we're going to pack occupying and came from, both of which are set to something. Although I'll be honest with you. Oh, sorry. No, what came from is not. It's just occupying. So when we go to pack occupying, let's see what happens there. So the ref pointer is going to be something, right? It's not deleted, so we set the ref index to something. Let's see what our ref ends up being. So it looks like that packs properly to me, right? That all looks good. So I'm not sure what the problem is there. But I'm going to go ahead and check, I guess, when we do the unpack to see what happens. Maybe there's something weird happening. I don't know why something weird would happen there. But that's the hero body, and it's the only hero body. So I'm not quite sure why we would end up in a situation where that wouldn't be correct. Well, okay. So I guess if we add it, it won't get unpacked. But that's okay. We'll skip it this time through, right? It won't have been added yet. I mean, technically that should probably be at the end, because we really don't want any in there that never got used, but I guess that's a separate issue. But yeah, we come through here. We shouldn't have any heroes. There should be no heroes at all, right? And so, yeah, we're never going to actually have a hero in there. And then the next time through, you would think, anyway, that our hero should have had that set properly, I would think. But I guess he doesn't. Let's see why not. All right, so we're going to grab the head and the body here, look at the body, and I want to look at those pieces of information occupying came from. So yeah, it totally lost its occupying information. Like, that's just set to nothing. So I guess like my unpack code is broken or something like this. And I want to find out why. Because obviously we're not going to get very far if we can't pack our stuff properly. And this code is kind of unnecessarily obtuse, right? Because this stuff will get a little bit more systemized when we actually start doing packing and unpacking. But for right now, it's sort of in an interim state, which does make it a little bit more difficult to use, certainly. But let's take a look. So this is going to be in connect entity pointers is when this will happen. And oh, well, to do re-enable this would probably be why that's not getting unpacked. Shockingly. All right, that's great. So yeah, in this case, we don't need head. We just need occupying and came from. I don't know. Looks like we're just unpacking and marking that as used, which is fine. So that should hopefully solve that problem of why those aren't getting unpacked. All right, so let's see. Well, no, I guess it didn't. But that was definitely a problem. You have to admit, it's not particularly friendly if you're trying to get a location when you're supposed to be occupying something and you never unpack it. All right, so who is this exactly? We're looking at a body here, and somehow it's occupying again got set to 0 though, right? But I don't understand why that would be, because the occupying should never really get set to 0. Let me double check that I didn't mess something up here. We do load traversal reference on the occupying. We double check and set the entity to make it occupy. But I don't know where is load traversable. So when we load it, we just see whether or not there's an index there, and if there is, we go ahead and get the entity out, which seems Fine. So I'm going to go ahead and set a breakpoint there. I want to see what happens when that unpacks. And you know what's weird about that too is I saw the fact that it was being occupied because it turned blue before, and so I feel like yeah, I feel like that was a little bit odd, but it's okay. Still got about 10 minutes left, so I'm going to go ahead and hunt this guy down before stopping. Excuse me. All right, so somewhere somebody is setting this to 0, which is not what I would have preferred they do. And what I'd like to do is take a look at which actual value ID this guy is, right? So every time we run it, it's guide 219, right? You can see here, let me back up a bit here. So, right, ID value 219. So what I want to do is just insert a little bit of code to help me out and say that when we're actually doing this unpacking, when we do connect entity pointers, I'm just going to make it so that, you know, if the entity ID value equals 219, you know, I want you to stop. Right? Probably more interesting would just be to give me a line to stop on. And then I can just set it and unset it as I wish. So now if I look at sim region here, when we actually do the connect up, I can just set a breakpoint and run. And now I can see what happens when we're about to unpack the entity that I know is the problem. And this is just a common thing that I do. You've seen me do it before, where I'm like, oh, it would be kind of finicky to try to step to that code all the time, because this code gets run a bunch of times every frame, and I don't want to spend a lot of time getting to it. So instead, I just put some code in that I know will only trigger when on the thing that I want to see, and so then we can see what happens. So let's at least see now what happens with occupying. So it looks like we're actually coming in wrong. So the point where we actually saved it out must also be erroneous or something, because by the time we get to the unpack, it's not correct, right? So let's try and figure out why that's happening. I can sort of keep this exact same concept going by going into what's the word for it? The world code, and when we do the pack, I can stop on the pack as well and see if there's anything weird happening there. So for example, on this guy, I could say like, oh yeah, tell me when this entity gets packed, and I guess, sorry, tell me when the source entity gets packed, and then we'll go from there. All right, so let's see both sides of the equation now. Here we are packing the source. And we can see that occupying is already set to null. So now I just have to kind of ask the question, all right, if this is entity 219 and it's already set to null, why was it set to null? When we're adding this player, why are we not adding the player correctly? Oh. Well, that's why. Because the head is not the thing which gets an occupying. Heads don't occupy, only the body occupies. So that's a little weird, right? Well, that kind of answers our question, right? Yeah, that kind of answers our question. You know what I might do? I might do something like this, where we can just set this value. Nah, I'll just do it later. It doesn't matter. Like, how long did that take to add? 12, you know, 2 seconds, 12 seconds, 15 seconds, 30 seconds, 75 seconds. Not very many seconds is the point. All right, so all I want to do now is go take a look at that code and see why we're ever looking at the occupying value for the head, because that just looks like I must have made a typo there. So let's go ahead and run and let it crash at the place it was crashing, because that should not actually be happening. Yeah, so why is the body what's going on with that? I may have mixed up. I may have mixed up which was which. And so another thing too is we could take this opportunity to, especially if that is the bug, take this opportunity to fix that. So let's see here. So the head is in slot 1 and the body's in slot 0. So I was wrong already, right? So what I'd like to do is I'd like to have a way of making this more robust, right? And it's a little tricky to do that because C++ don't really let you do this very well. But you see what the bug is, right? It's actually this goes into this slot and this goes into that slot. That was what was supposed to happen. So, you know, finish running this here. So that's the actual problem with why we were crashing. And so now we're back to normal. But you can see what we want to do is we want to make it so that it's much easier to put them in the right slot. So we want to make a way that we can take one of these entity brains that we have, and if we define a nice template here, not a C++ template obviously, but a, you know, I mean the actual textbook definition of template. If we have one of these, we want to be able to get the index by just figuring out what it would have been, right? So I'm going to make a macro for that because, like I said, there really isn't a good way to do it. And so, you know, I want to make something that's just like brain slot 4, and you basically say, oh, you know, what was the brain slot type you were looking for, and what was the member? I should do it this way, right? Type and member. So that I can say, like, oh, okay, the brain slot in this case is the brain slot for a brain hero parts, you know, which one is this here? Body. And this one is the brain slot for the brain hero parts head. So at least I know that they'll come back reliably. And so how do I do that? Well, this is an overlay on top of this array. So I know that if I take the offset from the base of that I could figure out where it was, right? So in other words, this structure has a set of entity pointers in it, and I know if I just look at how many bytes in a particular one of those is, and I divide by the size of one of these entity pointers, right, then I would know that's how far I go in, right? Divide by 8 bytes, right, the size of a pointer. So I can make a little macro that basically does that thing. What I could do is I could say, like, okay, let me cast, you know, like something like 0 to whatever the type is that I'm trying to talk about, which is the brain hero parts in this case, right? So I've got a brain hero parts here, and I know that if I had a pointer to brain hero parts, right, I could get out of that whatever the member was that I was referring to, right? So there's my member, and this is essentially, like, this pointer, right, would be how far in I would be from the start of the structure, right? If the structure was at 0, then, you know, if I took like the address, let's say, of this member, then that's how many bytes in I am from the start of the structure. Make sense? And so from there, I can figure out how many entity pointers in that is by just dividing by the size of one of those entity pointers, right? So I could say, well, all right, however many in that is, I could divide that value, you know, well, you know what, I wouldn't even have to do that. I could just use pointer arithmetic for it. If that's a pointer, I could just say pretend that pointer to that member is a pointer to an entity star, which actually I just don't even have to pretend. It is that, right? So I could just say, take that. Do I have enough parentheses here? Okay. Take that and subtract it from if you believed that 0 itself was a pointer to an entity star. Right? And that would get me back an index that says what the brain slot actually was. So hold on 1 second, and I'll walk that a bit. No operative found which takes right end of int 64. Oh, right. Sorry. I forgot to actually wrap that up in, well, you know what? I could just do this for now. Okay, so I think that should work, but we'll double check it. Yeah, it does. Okay, so let me just explain that one more time for people who think that's kind of crazy and weird, just what's going on there. So you know that this is just an overlay on this, right, because they're a union. So if I want to know which slot one of these would have lined up in, all I'm doing is saying, hey, take the address of it. If you assumed that you were starting at 0, how far in would I have to go to get to that member, right? And then I'm just telling the compiler, hey, by the way, how many entity stars is it from 0 to there, right? So that automatically has the compiler do that divide for me, right? Yeah, it's not pretty, but there you go. Now, this is exactly the kind of thing, too, that compiler vendors who basically are like trying to make programmers' lives more difficult will get and optimize in weird ways that because they're like, well, they don't come from the same memory pool because technically you never allocated and blah, 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 blah. That kind of stuff is the most annoying stuff ever. And I hate it. This particular one, I don't believe they optimize for it because there's really nothing you can do about it because they could have come from the same memory pool in this case. So I'm pretty sure this one's safe. But yeah, a lot of times you find yourself having to do operations like this because the language, I mean, it's pretty obvious the language should support this exact operation, which is to say I want to name slots in an array. It's kind of obvious, but of course it doesn't. And so, you know, a lot of times you have to compensate for it. And then it's super annoying when compiler vendors come in and make it hard for you to compensate for the problems in the language by making it impossible for you to use the things that compensate for the problems in the language. But, you know, there you are. So anyway, this is definitely that kind of a thing, but sometimes you need to do that. I would like this to return an actual brain slot value. So what I might do as well is I might sort of take this to be a little bit more of an official thing and say, okay, there's actually an inline function called brain slot 4. And that just needs to take whatever that pointer offset is, like whatever the actual distance is there or whatever. So we'll just say like, or you know, this is just the pack value or something, right? So this way we can put it into the right type of a structure. And again, I'm really doing this because we're not using the most modern dialect of C where I could have just done the bracket initializer for it there. So anyway, I could do brain slot results equals pack value, and then just return it. So that way we don't have to do this index nonsense anymore either, which is, you know, makes that also a little bit nicer. All right, so that's about it. We'll go ahead and go to the Q&A. And so we still have tomorrow. We got to finish up our acceleration stuff, but that's no big deal. We've gotten the brain stuff working, which is nice. Can we have a look at the C time stats so far? Yes, I believe that should be easy enough to do, right? C time is in. Yes, it is. Oops. So if we take a look at actually where are we storing it? Is it in build? I don't know where we're actually storing it. Sorry, I just don't remember where we decided to put this. Maybe it's just in code. Yeah. So you're just looking at stats. You just want to know this. Oops. I don't remember what the command is. Oh, minus stats. Sorry. So far, we've spent a total of 7 minutes and 29 seconds building, apparently. So that's in 400... We've built 417 times. That's a tremendous number of times. In 10 days. So we build an average of 40 times an episode. Can you imagine what it would be like Can you imagine what it would be like in if that was like you know, took a minute to compile or something? It would be brutal. Student basement. What will we do for the production assert? Well, in release mode, they don't compile in, so there won't be any. There is no production assert. May this brain system allow for things like two characters carrying a felled tree between them, with both of their brains controlling the movement of the tree. Well, I guess what I would say is I don't know that I would have chosen to use the brain system for that, because it doesn't necessarily... I don't know that that would be the best way to use the brain system, but you certainly could. The reason that I don't think I would use the brain system for that is because if you wanted to have two... Like, let's say you then wanted to have other types of people who are carrying the tree. Well, if the brain system is what determines who's carrying the tree, then you could, you know, it's easy enough to write a hero tree carrier. But now I gotta write, oh, what if one of the people was a monster? Now I have to have the tree monster carrying thing, and blah, 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 right? So I feel like maybe what you would do there is you would have probably, and this will probably happen, right? Our brains will probably have behaviors and stuff in them. There'd probably just be like a thing that's like, am I carrying a tree? If so, then I have special stuff that I might do on one side of the tree or something. I don't know. But I'm not sure that that would be the best way to implement it. I have to see. That's not really something on Handmade Hero that, since Handmade Hero is a single player game, I haven't really thought too hard about how you would need to do stuff like that. And whether there's something intelligent you would want to do there. All right, no more questions. We can end. I don't see any. I'm waiting, but I don't see no questions. I don't see no questions. I don't see no questions. No questions? No questions? No questions. Frosty Ninja, try not to make the brain self-aware. We can't have Stumpy over there taking over the world. Well, I think the person you should be more concerned about is Insobot, right? Because Insobot is definitely way more advanced than any of the brains that we're making on Handmade Hero. And so if something's going to take over the world, it's going to be Insobot. The Sizik. For brain types, why not an enum for the array indices? Well, the problem with array indices in this case is there's just more typing that I don't really want to have to do. But because then you have to constantly be like the thing in the brackets. We could do it. You know, and the other reason is you can mix and match them accidentally, right? I mean, you know, since nobody's asking any other questions, let me just go ahead and actually be 100% explicit on why I don't want to do that, because it's worth elaborating. So here's what we've got currently, right? And you've got Brain Hero parts, head and body. And so what happens there is when I'm actually doing that, the construction code would not be any different really, or any more error prone if you used enums. So in that case, I think you could use either fairly interchangeably. because there's no really clean way to make this work. I don't think. I mean, we could maybe do some, I don't know. The point being, no, I don't think there's much we could do here to make this less error prone. But the only reason that I wanted to maybe do it without the enums was because in the case where you're actually getting the code out, right, in here, this is a little easier to not screw up, in my opinion, because you can do stuff like that in the case where I've got a lot of these, and I can right? And I can make sure that everything comes from the same understanding, right? Now, if instead I was to do it this way, right? Well, probably I'd have to always do this, and I'd have to always make sure these were correct. And the reason is because it'd be real easy to accidentally use the enum from some other brain type in this entity, right? So you'd always have to, I'd have to at least always make sure I was very consistent with these prefixes, because if I did this, you know, maybe that's the wrong, that's not the hero body. That's some other body which is in a different slot, right? Because you're going to have a bunch of different types of brains. So this one kind of makes it so that it's scoped a little more properly in my mind, and that's the reason I didn't go with enums. Now, maybe I should have gone with enums because maybe that's really not a realistic error to be worried about, but that's what I was thinking. Josiah and Marriott, how would you go about making game entities moddable? Well, it depends what you're trying to mod about them. I mean, like, that's kind of... I feel like that's really not a question you can answer, because the moddable is not really... Moddable is not really a definition. Like, moddable doesn't mean anything, right? I mean, for Handmade Hero, the trivial answer is like, oh, well, all the source code's available, so if anyone wants to make different stuff, they can just make it, right? So the question is, like, what do you actually want to get out of the modding? Do they just want to be able to swap in bitmaps? Do they want to be able to define new behaviors that are combinations of existing behaviors? Or do they need to be able to write completely new behaviors that are, like, coded totally differently from other behaviors, right? And so if you're trying to... Okay, so it says... I was thinking of trying to find whole new types of entities. So if you're trying to find whole new types of entities, then you would probably have to do something where you load a DLL, right? If you wanted them to be able to find an entirely new entity, you would have to be able to load a DLL, right? Yeah, because the only alternative to that really is a scripting language, right? If you want to be able to load actual code in, you'd have to either load a scripting language or load a DLL that has, you know, code in it. And you know, for Handmade Hero, we definitely wouldn't ever do a scripting language, so that's kind of like a whole another project, right? To implement one of those, but you know, you could see loading a DLL or something, and then you would just have to do some kind of understanding of how you would marshal those behaviors, right? Like how you would assign them to different things. And obviously, because you run into the problem of defining a new type of entity, you would have to figure out how you're picking entities to begin with, right? And so what we would probably do is take those brain types, and the brain types would now be picked very much similar to the way the asset system picks things. So instead of specifically creating a brain type, instead you would have some parameters and it would, you know, do whatever. Josiah and Marriott, I guess there's no way to mitigate DLL's security concerns. Well, you can if you want to, right? That's like, for example, what Chrome does, is you can sandbox the DLL, and you can force it not to be able to load from anything. But certainly that's not something I would care about at all, because, you know, security concerns of that form, in my mind, that was Microsoft's job, and they abdicated their responsibility there, and so I'm certainly not going to step in and do Microsoft's job for them. You know, it's ridiculous that you could ever possibly have a security concern with a video game, right? Even the mere fact that that's even a concept is just kind of like a testament to how bad Microsoft is at their job, because it's ridiculous. I mean, it doesn't even make sense. The point of an operating system, just in general, was that there was no way for a game to be able to do anything on your machine, right? That was like the whole point of time-sharing operating systems in the first place. Well, I shouldn't say time-sharing operating systems, but of having protection in the first place. It was that so users couldn't do that. And so it's kind of silly that that's even the concept that you would even ever think of having to do security as a game developer is ludicrous, right? The only kind of security a game developer should be thinking about is if they're talking to like a server or something, because obviously that's something that, you know, that could be hacked in a separate way. But so yeah, that's just Microsoft's problem as far as I'm concerned. Static motion. All the brain code is now in the switch brain type. How many brains do you expect to have? What if we have 100 brains? Will you keep all the code in there? Well, I don't know that we would necessarily get rid of the switch statement, but we probably wouldn't keep the switch statement in line in this file. So there'd probably be a handmade brain.cpp, and then we'd have the switch statement there. Now, keep in mind that these brains will start sharing a lot of code. So the brain code will not be probably so huge. It'll probably be calling functions to do things that are common among brains. So that'll change a little bit. All right, we are out of time. So okay, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along the series at home, you can always pre-order the game on handmadehero.org, and it comes with the source code, so you can play around with it on your own. We also have a forum site you can go to if you would like to sort of ask questions, and or if you find bugs or anything like that you want to report. There's forums on there you can use. We have a Patreon page you can use if you want to support the video series. We have a schedule bot, which when I remember to upload the schedule, it tells you what the schedule is going to be. I forgot to do that this weekend. I'll do that tonight. We also have a past episodes guide that you can use to catch up with parts of the video series. It's really cool. It has time-coded links and everything. Brought to you by our very own Miblo. And that's about it. I will see you guys back here. I believe tomorrow will be another stream day, but double check the tweet bot, which I'll update tonight. But I believe we'll be back here again at 5 p.m. Pacific Daylight Time tomorrow, just as we normally are. That's about all there is to say about that. Thanks for joining me. I will see you guys tomorrow. Until then, have fun programming, and I'll see you on the internet.